Now we'll see the 8-point DFT using Radix to Ditfft. The input sequence is 8-point sequence. Therefore, n is equal to 8, that will be 2 raised to 3. That is similar to r raised to m. So r is equal to 2 and m is equal to 3. So for computation of 8-point DFT using Radix to FFT involves 3 stages of computation. The given 8-point sequence is decimated to 2-point sequence. From the results of 2-point DFT, the 4-point DFT can be computed. And similarly, from the results of 4-point DFT, the 8-point DFT can be computed. Let the sequence be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5 and x of 6 and 7. Now we are going to see that this contains exactly 8 samples, and the 8 samples should be decimated into sequences of 2 samples. But here, before decimation, they are arranged in bit reverse order. So let us see how they are arranged in bit reversed order. Now this is a normal sequence that is going from 0 to 7, and we have written the binary equivalent, that is 000, 001 and each of every term, that is 2, 3, 4, 5, 6, 7. Now to write in bit reverse order, we have to reverse the bit that are written in binary. So we'll reverse exactly the same way. That would be the first term 000. For the x of 1, that is 001, the reverse order will be 100, and similarly it goes on. Here we see that the order is changed. We will write the binary equivalent. So the first is x of 0 and x of 4. Then it goes on x of 2 and x of 6, x of 1, x of 5, and finally x of 3 and x of 7. So the sequence is x of 0 and x of 4, x of 2 and x of 6, x of 1 and 5, and 3 and 7s. That would be sequence number 1, 2, 3 and 4. Now we'll see exactly how these computations are performed. Now these are the 3 stages of computations in 8-point DFT. We can see that the sequence is written in bit reverse order. So now for each of the 2 sequences, we are performing a 2-point DFT. Again here the second point 2-point DFT and following goes on. Then again combine the 2-point DFT to get a 4-point DFT, and similarly it is done in the next step. Then at the final step we are combining a 4-point DFTs to get 8-point DFT, but here it is written in normal order. So this is a proper working and the flow of the DIT Radix to FFT. Now we will see the steps that will be performed in each block and the formula required to do this. Let us now examine the 8-point DFT. Let us consider x of n as 8-point sequence. Now we can decimate this in 2 parts. That will be f1 of n and f2 of n. This will be the 4-point sequence. Then we will again decimate into 2 parts. That would be v1 of n and v12 of n, v21 of n and v22 of n. This will be 2-point sequences obtained from f1 of n and f2 of n. Now seeing this table, we can exactly follow the path how x of 0 and x of 4 when the 2-point DFT is computed and combined together, we can follow the path. That path and the relation between the samples of the various sequences can be given by v11 of 0 is equivalent to f1 of 0 is equal to x of 0. v11 of 1 is equal to f1 of 2 is equal to x of 4. These paths can be traced exactly according to this flow chart. So there is no need to exactly calculate how it is going to, but we should write this to understand. v1 of 2, 0 is equal to f1 of 1 is equal to x of 2. v12 of 1 is equal to f1 of 3 is equal to x of 6. v21 of 0 is equal to f2 of 0 equal to x of 1. V2 of 1 is equal to F2 of 2, that is equivalent to x of 5. V22 of 0 is equal to F2 of 1, that is x of 3. V22 of 1 is equal to F2 of 3, that is x of 7. Now we are going to perform the 3 stages of computation, that will be first stage, second stage and third stage. So let us go for the first stage computation.